Hello everyone, my name is Brian. In today's video we're going to be talking about sharpening handsaws. But let's first introduce a few handsaws. So I'm first going to introduce this back saw. It's a Western back saw, which means it cuts on the push stroke. And we use this dovetail saw to cut dovetail joinery or different types of joinery in small work pieces. Now similarly, we use a saw like this, which is also a back saw, but filed differently to cut across the grain. This is a crosscut saw, and we use it again for small work pieces such as one I'm holding in my hand. And now we can contrast this to a larger saw or a panel saw. And this panel saw does not have a rigid backing on this back, and it's much larger. In comparison, you can see the difference in size when I hold the two up. When we take a look at this, the number of teeth per inch is much smaller. So we use this type of saw to cut full boards. So we're cross-cutting or going along the grain, which is called a rip cut, to cut large boards into smaller pieces. Here you can see a notch that we're going to cut out, and we're going to demonstrate a rip cut and a cross cut. A rip cut is done along the grain, so in the same direction as the grain, the wood grain. Here you can see the wood grain runs along the length of the board, and our cross cut is going to be done across the grain. We want different types of cutting teeth for a rip cut than we do for a cross cut, and this is in part because we rely upon human power and not a motor in order to make these cuts. And so the teeth that we have for a rip cut should be more like a chisel, whereas we want the teeth on our crosscut saw to tear these fibers and to provide an efficient cut. So we're going to make our cut by holding our rip saw or dovetail saw with our finger in a pistol grip, their finger pointed along the blade. And to start it, I like to use my thumb, position my thumb here, and then do pull back initially to start a kerf, a saw kerf, and then you just let the weight of the saw carry itself through the workpiece. So now we'll turn our workpiece. And we'll use a different saw now. We're going to use our crosscut saw. And it turns out that when you have a high number of teeth per inch, or the pitch is high for your saw blades, there's less of a difference between the rip or crosscut saw. But when you have a panel saw where there's only a few teeth per inch, you're down in the single digits, then it turns out that there's a big difference in the feel between the different saws. So we're going to use a crosscut saw anyway in this case, and I'll go ahead and start it again by using my thumb to get it along the line. Create my saw kerf. And then there we go, we've cut out our notch. So you've already heard me talk a little bit about some of the saw geometry that is important. The first one is pitch, but it's difficult for you to see this far away, so we've drawn some pictures to put up on the screen. So pitch, in this picture you'll see that's the number of teeth per inch or points per inch. And so this is typically described as how fine of a cut the saw will make. The higher that number, the finer the cut will be. The lower that number, the coarser that cut will be. Our next geometry that I think is important to know is the angles for our saw teeth. So here you can see that one of the angles is called the rake angle. So if you look at the blade from the side, as shown in the picture, you can see that the rake angle is the deviation from vertical, and the steeper that angle is, the more aggressive your cut will be, and the more relaxed that is, or the larger that angle, the less aggressive your cut will be. And you can tune this by rotating your file during the sharpening process. Fleam is another angle, and if we gun sight our cutting blade and we grab our file, this is the angle that we're sharpening at, perpendicular to, well, not perpendicular, but at an angle to our blade, as shown in the graphic. And so you'll see that the fleam angle is used typically in crosscut saws to tear the fibers. There are two other things I wanted to describe, and that is the set for a saw blade. And the set you really can't see along this length, but you can see it in the picture. The set is that leaning of each of the cutting teeth, the alternating leaning of the cutting teeth as you go down the saw blade. This helps clear the sawdust and make it easier for the blade to go through the workpiece. And finally is a saw tooth height. So the height of each of these cutting teeth. Sometimes when you get an older saw, it's not uniform, the saw tooth height, and so you end up jointing the top of the blade to make the top of the teeth all the same height. After you joint it, it's not sharp at all, and so you'll need to sharpen it. As you may already realize, we can file the teeth on these different types of spack saws or panel saws in different ways. We can file them to be for rip cuts, or we can file them to be for cross cuts. And just to make it a little more confusing, we can also file it in a hybrid type of way so that it could be used for either rip cutting or cross cutting. Here you can see I have a saw vise that we're going to use to hold our back saw, and this is typically put upside down into the vise, and we want the teeth to stick out so that we can see them and sharpen them. You just want them to barely stick out. You want to make sure that the gullet, or the bottom of the saw teeth, is just slightly above the line in your vise. Now, never fret if you don't have a vise in order to sharpen your saws. It turns out there's a workaround that we'll show you in a later video on how to make something yourself if you don't want to buy a saw vise. But one of the things that Talis will tell you is that it's helpful, since these teeth are really small, to have the vise at nearly eye level. So it makes it a lot easier to see the saw teeth, and you might use a pair of reading glasses or something like that to see the saw teeth. Whereas if you have this lower at the bottom of the vise, or just at the bottom, then you're going to be bending over and sharpening the entire time. And since there's a lot of teeth along the length of the saw, this might wear you out a little bit. Before we start sharpening, I wanted to make sure you're aware of something. The first is, what you'll see is that I will use a black magic marker to go down the teeth, and I'll make them all black first. And then as I'm using the file to sharpen the teeth, you will see that they will turn silver. And this will allow you to give you a visual indication of where you're at in the sharpening process. I recommend you start at the back of the saw, or at the heel, and move your way towards the front. This allows you to start with sharpening the teeth that are maybe the least important, and move towards the teeth that are most important, and as you pick up and refine your stroke, you'll get better at that, and as you get towards the front, you should be perfect by the time you get towards the front. We previously mentioned two important angles. The first one was fleam. So we're going to file for this rip saw at 90 degrees to the saw blade. And so our fleam is going to be that 90 degrees, or it's going to be orthogonal. So our file is going to be held like this and we push it through. But if we had a fleam on there for a cross cut, then we would have it at an angle like this. The other one is the rake angle. We set the rake angle by the rotation of our file, and here I recommend to try to just keep it consistent as you go through. You can work on improving that angle and setting that angle and keeping it at that angle as you go along the process. wanted to offer full disclosure on something. When I did the sharpening process the first time, I did a test cut, which is what you should do after you sharpen your saw. And after I did the first test cut, I didn't feel like the saw was a lot sharper. It didn't cut very smoothly. And so what I did is I played around with the rake angle and I resharpened it. I changed the rotation of my triangular file, and by doing this I made the rake angle steeper, and which would provide a more aggressive cut, and it feels much smoother whenever I'm taking cuts. I wanted to mention one last thing, and this last thing is that the size of the file changes depending on the number of teeth per inch that you're going to file on your saws. So the smaller files are used for the higher number of teeth per inch, whereas the larger triangular files will be used for a lower number of teeth per inch. And you can look at the manufacturer's website or other woodworking resources to find what size file you should use for different number of teeth per inch or points per inch. So we will put resources in the description below the video that you could use for finding these files.